So this is basically a demonstration on a master study program, which is master study in structural engineering using the American codes, British codes, and Dubai building codes, right? So you might have gone through the syllabus of this course, I assume that. So the duration of this particular course is like, if you talk in hours, okay, it will be like around 112 hours. Okay, basically it contains the lectures of 102. Okay, the lectures are 102, and the total watch time duration is 112 hours, right? So how much time it will take to complete this particular course is 112 hours, right? So it depends how much time you will give to this particular course in each day. So for example, let's say if you are willing to give like up to 1 hour in each day, right? So absolutely you will be managed to complete this course within the 100 days only, right? So the first 40 days will take to complete the superstructure design, okay, and another 25 days will take for the design of a foundation system, okay, and another 20 days will take for the structural detailing, okay, like you will learn the detailing of the foundation systems, okay, beams, columns, slabs, staircase, shear walls, all the structural members are there. For those you will learn the reinforcement detailing according to the American code, British codes, and the Dubai building code, right? So once the detailing is done, then we'll move to the drawing production part. Okay, so in that particular sessions, you will be providing the structural drawing to the clients, whether it's architect or a contractor, you will be providing the structural drawing to that particular person for the site executions, right? So can you see the screen?
Yeah, it's visible.
Okay, so we are going to use certain softwares. So the first one is AutoCAD. Now using the AutoCAD, basically what we'll do is we'll have the architecture plan. Okay, so for example, if you talk about the second project, which is the G+5 residential building. So for you can see here on the screen, this is the architecture plan. Okay, so as a structural engineer, what is your role? Your role is to design a particular building to resist the external loads. That is your basic purpose as a structural engineer, right? So let's say you want to construct like you want to build your own house, okay, so you will approach to architects, okay, and according to your requirements he will prepare the architecture plan. So once the architecture plan is done according to your requirement, the architect will approach to structural engineer for the safety of the building. Okay, so as a structural engineer, it's your job to design the building in a such a way that it can resist all the external forces that will be acting on the building throughout its lifetime. So okay, so basically this training program will start from architecture planning only. Okay, so once we will have the architecture plan of all the projects, and from this architecture plan we'll study the architecture plan first, and using this architecture plans we'll prepare the structural plans. Okay, so in the structural plan, as a structural engineer, you need to show the positions of a structural members. Okay, so for example, if you talk about the columns, you can see in the blue hedge, this is the column, and right beside this, you can see there is a column number mentioned, C1. This one number will be used, will be preferred for the detailing of the column, and below that, you can see this is the size of the column, 300 by 500. Okay, and also we have mentioned the sizes of the beam. So here this is the HB1, which is the horizontal beam number 1, and below that there is a size mention of the beam, which is 230 by 450 mm. Okay, and here these are the sizes of the slabs. So basically this is a slab number 9, and it is the two-way slab. So this is the sign of a two-way slab. Okay, and here the thickness of a two-way slab is mentioned 150 mm. Okay, here this is the sign of a one-way slab, and here this is the slab number 1, and there is a y direction mentioned because the slab is spanning in the y direction. Okay, so I'm just giving you the overview of this particular structural plan. Okay, so basically you will learn this from very basic only, like you will be learning like what column size you have to take initially. Okay, initially to prepare the structural plan, we are going to consider certain size of the column. Okay, so we'll take that particular size according to the American code. So basically, according to the American code, we'll take what should be the minimum depth, minimum width we have to consider for the column. So according to the American code, the minimum width we have to consider for the column is a 300 mm. Okay, and depth you can consider according to the final design. Okay, according to the geometry of the building, or you can say the number of stories in the particular building. Okay, as the number of stories increases, the size of the column will definitely increase. Okay, but we'll define the final size of the building once we have done the complete modeling and complete design of the building in the ETAP software, which will be used for the structural design. We'll talk about that particular one in a bit. Okay, so in the structural planning, basically we'll start from very basic. First of all, we'll determine what will be the size of the column initially, and then after we'll determine what will be the width for the beams. Okay, and then after we'll decide what will the depth for the beams we have to take. Okay, so and we'll provide sizes for and the labeling for every particular beam, as you can see in the structural plan. And then after we'll talk about the slabs. So in the slabs also we'll mention the labeling for the slab, like the number of the slab, and we'll mention whether the slab is spanning in a Y or X direction. Okay, we'll determine that according to the according whether the slab is a one-way or a two-way slab. And in that particular way, we'll define whether the slab is spanning in X or Y direction. And also we'll just take certain thickness of a slab. Okay, the final thickness will be decided according to the deflection. Okay, we'll talk about that one also later. So here you can see these are the slab labelings and these are the beam labelings. Okay, and these are the column labelings, and in the blue hatches these are nothing but the columns. Okay, and this vertical and horizontal lines you can see these are nothing but the beams. Okay, so in this way we'll prepare the structural plan, and you can see these these blue hatches, these are nothing but the shear wall. Okay, the shear wall is basically exactly similar to the column only, but it will have different purpose. Okay, so basically column can only resist the compressive forces, okay, which are going to act in a vertical direction, like in a Z direction. But the advantage of a shear wall is it provides more stability against the seismic forces. Okay, so basically the shear wall also provide the stability of a building against the gravity forces which will be acting in the Z direction, and also it will provide a stability to the RC building under the action of the horizontal forces, right? So, also we'll talk in a more detailed way about the difference between the columns and the shear wall once we get to this particular course. So this is the basics, or you can say the overview of this structural plan. And then after we'll prepare the column layout plan, in which we'll show the columns only, and we'll prepare the grid system for the column layout plan. Okay, and this is the central line plan. Okay, so this basically central line plan we have to use for the modeling or modeling of the RC building in the ETABS. Okay, so once the central line plan is done, we'll move toward the second software, which is called as a CSI Etabs. Okay, so CSI Etabs is basically a widely used software for the structural design and analysis. Okay, there are two softwares in the industry which are widely used. The first one is a CSI Etabs and the second one is a Staad Pro. Okay, so you might have seen the vacancies for the structural engineer who have the experience in a Staad Pro. Okay, but those companies are the steel companies mostly used Staad Pro. Okay, and most of the like 99% of the companies which are going to design the RC buildings, those companies mostly use the CSI tabs only over the Staad Pro. Okay, because a Staad Pro is very tricky to model and design the RC building as compared to the ETABS, and ETABS gives you more accurate result as compared to the Staad Pro. So that is the reason why most of the structural consultants use CSI ETABS over the Staad Pro. So CSI ETABS will use for the structural design and modeling and the analysis of the RC building. Okay, so I will just give I'll just show you one model I have that you will be preparing through this program. So let me just open that. Let's go to the second project. Right. Okay, whatever the software will be required for this particular training program, those softwares will be provided from my side. Okay, so basically you will be getting the crack version of the softwares which you can use for the lifetime. Okay, there will be no trial version of 30 days and all. You can use the softwares for lifetime for the free only. Okay, so as you can see on the screen, this is the ETAP software, and this is the model that I have prepared for this G+5 building. Okay, so this is the 3D view. Okay, so basically, in the Etabs, you can do the modeling of any particular building using the two methods. The first one is the grid system method, and the second one is using the center line plan method. Okay, now we have already seen the center line plan in the AutoCAD. This is the center line plan. So what we are going to do is in the second method, which is the structural modeling using the center line plan. This is the second method of a structural modeling. So in this particular method, we'll be importing this center line plan into Etabs, and then after we'll be proceeding with the structural modeling in the Etabs. Okay, so if you go to the plan view, let's say the first floor, you can see these are the columns. Okay, these are the beams. You can just right click on the property and you can go to the assignment section. You can see the beam property here, beam BM 230 by 600. So here 230 is nothing but the width of beam and 600 is nothing but the depth of the beam. And these are the external load applied on this particular beam. So there is basically a wall load that is applied on this particular beam. So we'll get to know about the what are the external load that will be acting on the building and how much amount of load you have to apply on the particular slab and the beam. Okay, according to its function. So if I just go into define section here, and if I just go into material properties, okay, so here you can see certain grades of concrete and the grade of steel are added. So this is according to the Indian code showing as of now. So HYSD 500, this is the grade of steel, okay, and M30 grade of concrete. According to the IS 456, these are taken. But as you are going to join a program based on American codes, okay, so there will be different grade of concrete and different grade of steel, right? So like the grade of concrete will be this one only 4000 psi, okay, and grade of steel will be different, okay, like this one A615 grade 60 steel. Okay, so here in this particular tab, you can just define the material properties like the grade of concrete and grade of steel. And again, if you go for the define section, and then in the section properties, here you can define the frame sections like the beams and column that will be used for the structural modeling. Okay. Also, you can define the slab sections. Okay, according to the thickness, whether the slab is a 150 mm thick or a 125 mm thick. According to that one, you can define the slabs. So you can see here there is a slab of a 125 mm thickness. There is a slab I have used of a 150 mm thickness, and there is a staircase slab of a 150 mm thickness. Then after, in the section properties, I have also used the shear walls. Okay, so you can see the wall 250. So 250 is nothing but the thickness of a shear wall, or you can say the width of the shear wall in this case. Again, I'll go to define section, and now I will go to, let's say, load patterns. So here using the load pattern section, I will get to define the external loads. Okay, so there are the various types of external loads that will be acting on the building. So as a structural engineer, you need to be quite sure about what will be the amount of particular external load that will be acting on the building. Okay, because the uncertain load can affect on, like, can make a failure in the particular building, right? So you need to be quite sure about the amount of external load that will be acting on the building. So there are different type of external load. The super dead load is there, live load is there, then the seismic loads are there, then the wind loads are there. So all those loads will be taught to you from very basic. Okay, so if you go to a define section and then load patterns, and here you can see the dead load is there. So here basically a dead load is nothing but the self weight of the members. Okay, self weight of the member you can easily calculate by just multiplying the density of concrete to the volume of the particular member. In that case, you will get the dead load of the particular member. Okay, and also you can define the super dead load. The super dead load is nothing but the external load that will be acting on the structural members. Okay, for example, if you consider the slab. So on the slab, you will be providing the floor finish and the floor tiles. Okay, so it will have certain load. So that particular load will be called as a super dead load. Okay, so in this case, here the super dead load is included in the dead load itself. Okay, you can also define a different load pattern for the super dead load, but I have included that in the dead load only. Now here the live load I have taken. Okay, so then after the wind load also I have defined. You can see wind WX. This is nothing but the wind load. As you can see, the load type is wind. Okay, and the code I have used for the application of wind load is a Indian IS 875. Okay, for the in this particular training program, the American code ASE 716 will be used. Okay, if I just unlock this model, let's say I will go to define and then load patterns. Let's say I will define here wind X. Okay, just a minute, wind X. So load type, I will select wind, and then after self-weight multiplier will be 0. Okay, the self-weight multiplier you have to consider it 1 only for the only in case if you want to consider the self-weight of the members. Now the self-weight of the members will be considered in the dead load itself. So in the dead load pattern only you have to consider the 1 as a scale factor for the self-weight multiplier. Okay, in the wind load pattern you don't have to consider 1 for the self-weight multiplier, right? This will be clear to you in the more detailed way once we get to the program. For now, I'll just leave it as a 0. And here the last section is about the auto lateral load. Load type wind, self-weight multiplier will be 0. And in the auto lateral load section, let's say I want to apply the wind load using the American code ASC 716. So I will select this particular code. You can select any particular code according to your convenience. Okay, if you want to design the building that is located in the India, so obviously you will use IS 875 2015, which is this one. Okay, and if you are going to design the building which is going to be based in a UAE, for example, so in that case you will be using ASCE 716, right? So you will select this particular code and then you will just click to add new load, and you can see in this tab the load is added. Now you can just modify it, and you have to change certain parameters and the factors according to the code you are selected, which is ASCE 716. Okay, so there are two methods to apply the wind load. The first one is a diaphragm method, and the second one is a shell object method. We'll talk about both of these methods in a more detailed way once you get to the particular course. So diaphragm method is there and the shell object method is there. So mostly we prefer the diaphragm method only because it will give you the accurate results, right? So here in the wind pressure coefficient, you have to calculate the windward coefficient and the leeward coefficient. This basically windward and leeward coefficient depends on the height of building, or you can say the width and the length of building. According to the length and the width of building and the height of building, you will get to calculate the windward coefficient and the leeward coefficient from the ASCE 716. Okay, then after the wind exposure parameters you have to provide. So the first parameter you have to provide is a wind direction, like in which direction the wind will be acting. Okay, so if you just modify it, let's say 0 degrees there. So if you are going to apply the wind in X direction, so direction angle you have to keep it as a 0. So and if you are going to apply the wind in a Y direction, so in that case a direction angle will be 90 degree, right? Then after the cases are there, so 1, 2, 3, 4 cases are there. These are basically depends on the exposure, like whether the surrounding buildings are closely spaced or not. So according to that you have to select the particular case. Okay, then after E1, E2 ratios are there. Okay, these are basically eccentricity ratios, which you can calculate from this particular sections mentioned here in the Etabs only. So for the calculation of here for E1, for example, you have to refer figure number 27.38 from the ASCE 716. Okay, so in that particular figure, you have to make certain calculations in order to get the value of E1 ratio. So you'll take that value, particular value here, and you will enter it here. Then the next thing you need to provide is a wind coefficients. Okay, so basically you need to provide the wind speed, like what will be the speed of the, like basic wind speed you need to provide. Okay, like what will be the speed of the wind acting on the particular building on the particular location. So for example, in this case, let's say the building is located in the Mumbai. So according to the ASCE 875, okay, so different cities have a different basic wind speed. Okay, so basically your wind force that is going to act on a building, it ultimately depends on the basic wind speed. Okay, so the basic wind speed you need to calculate from the suitable code, and you need to enter the value of the basic wind speed here. Okay, then after the exposure type is there. Okay, so this one basically depends on what is the function of building, whether the building not the function, basically it depends on the climate, or you can say the exposure, whether the building is located in a rural areas, okay, or it is located nearly to the sea. So according to that, these are the three types of the exposure: B, C, and D. So according to the particular type of building, you have to select the suitable exposure type. So ground elevation factor is there. This basically depends on what is the slope of ground on which the building is going to be constructed. Okay, so if the slope of the ground is more than 3 degrees, then in that case you have to calculate the ground elevation factor from the different section of the ASCE 716. And if the ground slope is less than 3 degrees, then in that case you have to consider the ground elevation factor as a 1 here. Okay, then after the topography factor is there, which is also called as a KZT. So for the calculation of a KZT, you need to again refer to the different section. Then after the gust factor is there. This gust factor basically depends on whether the building is a flexible building or a rigid building. Okay, we'll talk about more about what is the rigid building and what is the flexible building. It basically depends on the frequency of building. We'll talk about the frequency also, and the frequency again depend on the time period of the building. Okay, we'll talk about we have to learn a lot in the structural engineering field, right? So everything will be clear to you from very basic only. Then after the directionality factor, okay, this one also you can calculate. And then after the exposure heights, you need to mention. So basically here in this particular section, you need to mention like what stories will be exposed to the wind forces. So bottom story, let's say here the ground will be there. Okay, so base is nothing but the foundation level. So basically your foundation will be beneath the ground. So it will, the wind, like the foundation will not be exposed to the wind forces or the wind, right? So ultimately there will be no wind force that will be acting on the foundation level. So in this case, bottom story, you don't have to consider the base. You just have to consider the story which is on the ground level, which is the ground floor in this case. Then the top story will be a topmost story, which will be whatever the story it is about the terrace floor or the roof floor. So in this case, it is overhead water tank. So I'll select that and I'll just click to OK. So in this particular way, you can just add the wind force. Now let's say I want to apply the seismic force. So let's say I will define it as let's say SCI seismic. Let's say seismic force in X direction I want to add. So this is the load name I will give, and load type will be, let's say I will select seismic. Okay, and then after self-weight multiplier, I will keep it as a 0 only because it is the external loads. Okay, the self-weight multiplier will be 1 for only a dead load only, like the self-weight of the members. So let's say I want to apply the seismic load using the American code ASCE 716. So I'll select this particular code and I'll just click to add new load. Now, once you add it, just modify it so that you can change the parameters according to the ASCE 716. Right now, here the first section is about the direction and eccentricity. We'll talk about the eccentricity. What is the eccentricity and all in the course only. So for example, let's say here, I want to apply the seismic load in X direction only, right? So as I want to apply the seismic load in X direction, so I will only consider X direction plus and minus eccentricity. I will neglect this Y direction plus eccentricity and Y direction minus eccentricity. I will only keep this X direction plus minus eccentricity. Now the eccentricity ratio, by default, you have to keep it as 5%. Okay, the next section is about the time period. Okay, so time period, for now, if I just talk about the briefly about the time period is nothing but the time taken by a building to complete one oscillation, like a one vibration under the action of a seismic load. Okay, we'll talk about like in a practical way, like what is the time period and how building will behave once the actually once the earthquake hits the structure. Okay, we'll talk about that. Now here you have the three methods to apply the time period. So there is a approximate method using which you just need to calculate the time period coefficient and the X factor from the ASCE 716. You have to select the particular factors here, and according to that, the seismic load will be calculated. You can leave it as a program calculated also. Here also you have to select the same time period factor and the X factor, and also, you can manually calculate the time period. Basically, according to the ASCE 716, the formulas are there to calculate the time period. Okay, so we are going to calculate the time period according to those formulas only, and whatever the time period will get in a seconds, that will be that we have to enter here only. Okay, then the story range you need to provide, like what stories will be exposed to the seismic forces. So, for example, topmost story will be overhead water tank, and the bottom story will be base only. Now, why we are selecting the base here? Base, let's say base is nothing but the foundation level. So what is a seismic loading? So basically a seismic load is nothing but the, let's say the building is there and the foundation is also there. So seismic activity is nothing but the ground shaking, right? So ground will be shaken from its original position. So basically it will exert certain amount of horizontal force on a foundation system, right? So here bottom story you have to always select as a base in the case of seismic loading. Okay, now here you are having the seismic coefficient, site class, and all those factors. So those factors all you have to calculate from the ASCE 716 again. Then the response reaction, response modification factor are there. So this basically depends on what types of frame you are going to use, like whether you are going to use ordinary movement resisting frames or special movement resisting frames. Okay, we'll talk about that one also. What is the ordinary movement resisting frames, special movement resisting frames? Okay. Now, the seismic coefficient factor is there, which is also depends on the type of frame you are going to use. Then the deflection amplification factor, which is also called as a CD. Then occupancy importance factor. This one basically depends on what type of structure it is. Like whether you are going to use this building for as a hospital building or a commercial building or a residential building. According to that, the occupancy importance factor varies. Okay, so once you provide all these factors, okay, your seismic load and the wind load, whatever the coefficient you have provided here, okay, according to those coefficient, the wind load that will be acting on a particular building will be calculated by the ETAP itself. Okay, so I will just delete these loads for now. So here wind X, wind Y, EX, EY. So here wind X and wind X, WX, you can see this is nothing but the wind load in X direction, and WY, as you can see, this is nothing but the wind load in a Y direction. And EX is nothing but the seismic load in X direction, and then EY is nothing but the seismic load in Y direction. Now here I have already provided the factors and the coefficient according to the Indian codes. Now I will just analyze this structure and I will show you how much amount of seismic load that will be acting on the particular story of the building. Also, I'll show how much amount of wind force that will be acting on the particular story of this particular building. So I will just analyze this first. So I'll just simply click on this one. Okay, so in the first project, we'll start this program with the first project. In that particular one, you'll learn the basics of the ETAPs. Okay, like you will learn how to define the structural members. Okay, how to define the grade of concrete, grade of steel, and also you'll learn how to do the structural modeling of the building, like how to draw the columns, slabs, beams, and shear walls in the ETAPs. Okay, and also you'll learn how to define the external loads and all. So in the first project only, the basics of the ETAPs will be taught to you, and in the second project, you will learn certain advanced part of the ETAPs. Okay, like if I talk about the advanced part is nothing but the calculation, like the manual calculation of the external loads. Okay, so you'll get to manually calculate the super dead load, live load, seismic load, and the wind loads. Okay, once you calculate those loads manually, then we'll apply those loads on the ETAPs on the particular building. Then after we'll analyze the building and we'll check whether the building is stable or not to resist the external forces. Right. So as you can see, there is certain colors here, which is called as a contour in the terms of structural engineering. So right now, if I just go into display section and then show tables, and let's say in the structure output, base reaction. Okay, so this base reaction table will give you the value of how much seismic force or the wind force that will be acting on a base of the particular building. Like base is nothing but the foundation. So in this particular case, you can see EX, which is nothing but the seismic force in X direction. So this much amount of seismic force that will be acting on the base, which is 1022 kilonewton. Fx, this is nothing but the force in a X direction, and this Fi is nothing but the force in a Y direction. So if you go for the Ey, you can see the seismic force in a Y direction is like 800 kilonewton. Right now, if you want to see the wind, you can go to the display and then story response plot. Okay, here let's say I will select story shear. Okay, this display type will basically give you the amount of external forces that will be acting on the particular story. Okay, and in the case and combo section, I will select the external load. Okay, like the load due to which like the amount of load that I want to see. Let's say, for example, I want to see the seismic loads that will be acting on the particular story. So here I will select the seismic load in X direction or Y direction. So I'll select EX. Okay, so this much amount of seismic force that will be acting on the base, which is 1022. Okay, on the ground floor it is 1022. On the first floor it is 1010 kilonewton. On the second floor it is 963 kilonewton. On the third floor it is 858 kilonewton. On the fourth floor it is around 670 kilonewton. and on the 5th floor it is around 377. Okay, on the terrace level there is certain different forces there. So this is about the, you can say, the calculation of external loads. Okay, now if you just want to see the amount of super dead load and the live load that is applied on the slabs, so what you can do is you can just right click on the particular slab, just go into the load section, and you can see here, you can see the load applied here. So here basically a dead load of intensity 1.5 kilonewton per meter square and the live load of intensity 2 kilonewton per meter square, it is applied on this particular slab. Okay, so basically we are going to manually calculate the super dead load and the live load according to the suitable code, and we'll apply this manually calculated load on the particular slab according to its function. So if basically, for example, let's say there is a living room. So according to the AC 716, there is a different amount of super dead load. Sorry, there is a different amount of live load suggested by AC 716. So for example, let's say the live load that will be acting on the living room for the residential building, it is 3 kilonewton per meter square. So we'll take that load and we'll apply that load into Etabs. Okay. And for the super dead load, we'll manually calculate the load according to the floor tiles that you are going to provide, according to the ceiling and floor finish that you are going to provide. Okay, so according to the function of the particular slab. So for example, there is a kitchen slab. It will have the different amount of live load as per the AC 716. There is a bedroom slab. This will also have the different amount of live load according to the AC 716. So we'll calculate that load according to the code and we'll apply that into the Etabs. Now here on the Etabs, I have already applied the wall load on the beams. So you can see the certain numbers here like 2.4, 12, 2.4, 2.4. These are nothing but the amount of load that is applied on this particular beams. These horizontal lines and vertical lines, as you can see, these are nothing but the beams. Okay, if we just select this line and if I just right click, just go into assignment section, you can see the section properties like BM 230 by 600. So this is nothing but the beam property, and this much is a load applied on this particular beam. And in the design section, as of now, there is nothing because I have not designed the structural frames yet. So will be no reinforcement will be shown here. Once you design those concrete frames, in that case only you will get certain data there. I will show you that one also. So let's go into 3D view. So you can see this is the wall load applied, 12 kilonewton per meter on this particular beam. And here it is somewhere around 2.4 kilonewton per meter. Okay. So basically how we'll do is, first of all, we'll do the structural modeling in the ETAP. Now, once the structural modeling is done, we'll manually calculate the external loads. First of all, we'll do the manual calculation of super dead load. Okay, and then after we'll calculate the live load from the AC 716, and then after we'll apply that load into the ETAPs on the particular slab according to its function. Now, once the super dead load is and the live load is applied, we'll do the manual calculation of a wind load. Okay, we consider certain project, and according to the height of a building, according to the width and the length of building, we'll calculate the wind load. Okay, for that particular building. And then after we'll apply the wind load on the ETAPs also. We'll see what factors we have to consider and from what table and from what particular section we have to take the value of those particular factors. From the AC 716, we'll talk about that one also. Now we'll apply the wind load, and after the application of a wind load, we'll move towards the application of a seismic load. So first of all, we'll do the manual calculation of a seismic load so that you can get the basics of the seismic loading. Okay, so once the manual calculation of the seismic loading is done, we'll apply the seismic load on the particular building. Now, once all those external loads are applied, okay, we'll check whether the column size, shear wall size, or the slabs, beams, whatever the structural members we have taken, whatever the sizes of the structural members we have taken, are those sizes are sufficient or not to resist the external loads. So to check whether the building is stable or not, we have certain stability checks. Okay, like according to the American code, we have I guess 8 to 9 stability checks. Okay, so there is a check for the deflection in the slab. So we'll get to check in that particular a lecture whether the thickness we have considered for the slab is enough or not to resist the super dead load and the live load that will be acting on the particular slab. Okay, whether the slab is unstable, let's say the deflection is more than the limit as suggested as per the American code. So in that case, we have to increase or decrease the depth of the slab. We'll discuss about that one also. The second stability check will be about the maximum displacement of the building due to the action of the wind forces. Okay, like there will be certain limit according to the American code, like how much there should be a deflection in the building due to the action of a wind load. Okay, so if the deflection in the building due to the action of a wind load is more than the limit specified by the American code, so obviously in that case we have to increase the sizes of the vertical members. So your vertical members are your vertical members only are responsible to resist the horizontal forces, which are like the wind forces and the seismic forces. Okay, so during those stability checks only we'll get to finalize what will be the sizes of the particular members, like what will be the final size of the beam, column, slabs, and the shear walls. Now once those sizes are finalized, we'll move towards the foundation design. Okay, so first of all, in the ATAS, basically we are going to design the members again. So let's say I will design the concrete frames now. I'll show you. So you can see there is a yellow line going on. So basically ETABS is analyzing, like designing each particular beam and column here in this building. Okay, and ETAB is checking whether the each member is okay or not to resist the external loads. It will take some time. Okay, so here you can see design is completely done. Now, if I just go into plan view, let's say plan, and fourth floor, I will select apply. So as of now on the screen, you can see certain numbers. So for example, if I just zoom in here, this is the one horizontal beam. If I just show you in the structural plan, this is the horizontal beam, HB number 5. Okay, so here you can see 211, 0, 211. This is nothing but the top reinforcement required for this particular beam. Okay, and at the bottom side, you are getting 211, 265, 211. This is nothing but the bottom reinforcement required for this particular beam. So whatever the reinforcement it is showing here, according to that, according to this particular only, we are going to provide the reinforcement detailing for this particular beam in the AutoCAD. Okay, so this is about the main reinforcement, which is also called as a longitudinal reinforcement. Now, if you want to see the shear reinforcement, so in that case, I will click on this concrete frame design. I will go to the display design info. And here in the display output section, instead of longitudinal reinforcement, I will select the shear reinforcement so that I will get to see the shear reinforcement required for the each individual beam. I'll just click on apply and you can see 255 mm square. This is the shear reinforcement required at the left hand, and at the middle, the 255, and at the right hand also 255. This much shear reinforcement are required for this particular beam. Okay, so the reinforcement detailing we are going to carry according to the whatever the results we are getting from the ETABS and the SAFE software. Okay, so these are the things you learn in the ETAP software, which will be a second software. Now the third one is a SAFE software. Okay, so basically SAFE we will use for the design of the horizontal members, like specifically horizontal members like slabs and the foundation system. Mostly we will use the SAFE software for the foundation design only. So in this particular SAFE software, we are going to design a isolated foundation, combined foundation, then you can say the raft foundation, and then pile cap foundation. So these are the 4 types of the foundation that will be designed on this CSI SAFE. Okay, so if I just open any particular foundation model, I will show you. So this is the SAFE. Okay, this is not complete plan. Let me just open another one. Okay, so this is basically a raft foundation, as you can see. So this is a raft is nothing but the single slab that will be supporting each individual column of the building. Okay, so as you can see, this is nothing but the column only, and this is a raft, and this is nothing but the drop panel, or we also called it as a pedestal. Okay, so in this particular SAFE software, we are going to design a different types of foundations. Okay, so we'll start with the isolated foundation because it's a basic one. Okay, not the isolated. First of all, we'll do the theoretical study of the various types of foundation, like what are the different types of foundations are there, what are the function of those foundation, and what type of foundation you have to use depending on the particular project. Whether the like it depends on the architectural perspective of the particular project, like how much closely spaced the columns are, and what is the property of the particular soil, and what is the load from the superstructure. So according to these three particular parameters, your selection of the particular type of foundation matters. Okay, so we'll get to study about that one also. And once the theoretical study is done, we'll discuss about what are the different types of failures are there for the foundation. So there is a bending moment failure, settlement failure, then one-way shear, two-way shear failure. We'll discuss about all those in a detailed way. And then after we are going to design the foundation into this SAFE software. So we'll start with the isolated foundation, then combined foundation, then we'll go for the raft foundation, and then after in the last we'll cover the pile cap foundation. So these four projects will be done in the SAFE. Okay, and the size of the foundation that is going to be required for the particular project will be calculated using the Excel sheet. Okay, and those Excel sheet will be also provided to you. And the fourth software is a SAP 2000. Now, this software we are going to use for the design of infrastructure projects like the overhead water tank and the underground water tank. Okay, we'll consider certain capacity for the water tanks, and then we'll design those water tanks into the CSI SAP 2000 software. Then after CSI Detail is there, which will be used for the reinforcement detailings of the structural members like the beams, columns, slabs, shear walls, and you can say the staircases. Okay, the purpose of the Staad RCDC is also exactly similar to the CSI Detail, but whatever the detailing we'll get from the CSI Detail and the Staad RCDC, it is not up to the Indian standard. It is not up to the standards. Okay, so because the thing is, whatever the drawing detailing that will be generated through the software, the curtailment lengths, okay, like many factors are there which will be not up to the standards, industry standard, right? So for that particular purpose, it will be better if you just do the detailing in the manual way. Okay, if you just do the detailing by yourself, you will get to understand many things from the basics only. So the main these two softwares you will learn just for the learning purposes, basically, like you will get to learn how to do the reinforcement detailing in the CSI Detail and Staad RCDC. But our main purpose will be to carry out the detailing in the AutoCAD only. Like we'll do the detailing in the AutoCAD itself. Let me just show you for the first project how the detailing will be done. Okay, so the detailing will start with the foundation first. So first we'll prepare this foundation layout plan, as you can see. So in the foundation layout plan, we'll mention the size of every particular footing. Okay, and here we'll show the reinforcement detailing. So this is the bottom reinforcement required for each individual footing. So 12T at 100 mm center to center. This is nothing but the spacing, and 12T is nothing but this is the 12 mm diameter bar that we are going to use at the 100 mm center to center spacing. Okay, and along the y direction, this is the detailing 12T at 100 mm center to center, and along the x direction, this is the detailing 12 mm diameter bar will be used at the spacing of 150. So we'll get to calculate this reinforcement details that are required from the SAFE software only. Okay, for each individual footing. And once the bottom steel detailing is done, we'll just draw the sections for the particular footings. Okay, so here you can see section CC, section BB, and section AA. So all the sections will draw from very scratch only. Okay, And here you can see footings text schedule. So these are the footings marked. The length and width and the depth of each individual footing is mentioned here. And what is the bottom reinforcement that it will be provided along the longer span and the shorter span, it is mentioned here. Okay, so we'll prepare everything from the beginning only. We don't have any kind of reference file here. We'll start it from the very scratch. Okay, once the foundation detailing is done, then the next thing you need to do is the column detailing. Okay, so for the column detailing, you will require a column layout plan. So we'll prepare the column layout plan first, and then after we'll do the reinforcement detailing for the column. So here you can see this is the reinforcement detailing. Okay, so here in this particular column, you can see the width is a 230 mm and the depth is a 500 mm. And in this particular column, we are going to use a 20 mm diameter bar. Okay, so basically we are going to use 8 bars of a 20 mm. Okay, which will give you the rebar percentage of a 2.18%. So in the Etabs, you can get the rebar percentage required for the each particular column. Just go into 3D view. Okay, here display design info. Here I will select rebar percentage and apply. For now, let's say for the clarity, I will hide the beams, floors and walls. So as you can see, certain numbers are there. For example, here 1.12. So this is nothing but the rebar percentage. So according to this particular rebar percentage, we are going to determine what diameter of a bar the column we need to have, and what numbers of bar it will require. So according to that particular rebar percentage, we are going to calculate what diameter of bar it will require and how many bars that will take. Okay. Also, we are going to draw elevation sectional view for the columns. Okay. Now, once the column detailing is done, we'll proceed with the beam detailing. So we'll have the beam layout plan here. This is the beam layout plan, and here the beam details are there. Okay. So as I told you in the Etabs only, we are going to take the longitudinal reinforcement from the Etab itself, and whatever the reinforcement we'll get, according to that, we'll provide the bars here. So for example, here on this particular HB1, 2 bars of 12 mm are required for the straight. Okay. And we are going to add one extra bar of a 16 mm here at this particular end. Okay, and this 900, you can see this is the curtailment length, which is 900 mm. Also, you will get to see how you can calculate this curtailment length. Okay, and how you will also understand what diameter of bar you have to use for the beams. Okay, and how many numbers of extra bars you have to give. Even if you have the zero knowledge about the reinforcement detailing, you don't have to worry. We'll start from very basic only. Okay, we'll prepare the skeleton first, and then after we'll decide what diameter of bar the beam will require, and how many numbers of bar we have to provide in the particular beam. Now you can see this 400 mm. This is nothing but the hook length. Okay, also we'll get to calculate what will be the hook length for the particular beam. Okay, this is the column number 1. Okay, and this is the HB number 1. This is the horizontal beam number 2. At the bottom side, you can see this is this box. Here in this box, the shear reinforcement is mentioned. Okay, so for the calculation of a shear reinforcement, we are going to use Excel sheet, and here in the Etabs only, we'll have the shear reinforcement. So we'll take that shear reinforcement, we'll provide that into Excel sheet, and we'll get the stirrups that the shear reinforcement that is required for the particular beam, and we'll paste it here on. So we'll provide the beam details, okay, for any particular floor of the particular building. And when the beam detailing is done, then we'll carry the detailing of the slabs. Okay, so basically here you can see this is the two-way slab. Okay, the bottom and the top reinforcement provided for the two-way slabs. Also, we'll do the reinforcement detailing for the one-way slabs also. Okay, so you can see here these are the sectional views for the section A and B here as mentioned. Okay, and these are nothing but the staircase detailing. Okay, so detailing will be done in the AutoCAD only throughout, so that you can do it clearly. Okay, so if you just learn the detailing through this CSI detail or the Staad RCDC, you will not get to understand many things, like what should be the diameter of bar you have to use for the particular beam, and what should be the curtailment length. Okay, you will not get those particular things properly because the detailing will be automatically generated. Okay, so you won't get these particular things. What should be the curtailment length? What should be the hook length? What should be the extra bar? So if you do this in a manual way, if you do this on your own, so you'll get these things very clearly, right? So that is our main purpose. We'll calculate out the detailing in a manual way using the AutoCAD only. Okay, so Staad RCDC is there, and then after another software will be called, which is called as a Procon. So Procon will be used for the design of pile cap. So basically, for the pile cap, what we are going to use is we will have the soil report, and according to that soil report, we'll see what diameter of a pile require. Okay, so whatever the factors are there, whatever the coefficients of there for the soil, we'll mention those coefficient into Procon, and in that Procon we'll mention a diameter of a pile, and according to that we'll calculate the capacity of the particular pile. So the Procon will be used for the one particular project only, which is G+12 building. For that one, we are going to design a pile cap foundation. So for that one, we are going to use Procon software. Okay, and these are the codes that will be covered throughout this training program. Okay, and these are the projects. Okay, now you might be confused about how the training will be conducted, how the lectures will go. So basically, we'll start with the first project, which is the G+2 commercial building. So in the G+2 project, first of all, you will learn the basics of the Etabs. Right. So whatever is mentioned here in the second chapter, this will be covered in this first project. Okay, then after, in the second project, which is the G+5 residential building, in this particular project we'll start from the chapter 1. Okay, first of all, we'll just work on certain basic drawing tools. We'll understand the architecture plan, and then we'll prepare the structural plan and the central line plan, column layout plan. All those plans we will prepare in the AutoCAD. Once those plan is prepared, we'll prepare the structural model in the Etabs. We'll manually calculate the external load. We'll apply this load, and we'll perform the stability check. We'll check whether the building is stable or not. Once the stability checks are satisfied, then we'll go for the third project, which is the G+9. Okay. First of all, we'll do the superstructure design in the CSI SAFE. Sorry. So when the superstructure design for all this project is done, then after only we'll go for the foundation design for the all these projects. Okay, so superstructure design will do for all these projects. Once it is done, then we'll go for the foundation design of all these projects. And once the foundation design is done for all these projects, then we'll go for the reinforcement detailing. Okay, so we'll do the reinforcement detailing for all these projects, and when it is done, then we'll go for the design of this underground water tank and the overhead water tank into SAP200. Right, so this is how your program will be done. Okay, so this is complete details about this particular program. If you have any doubt, then please ask me now. Okay, Afzal, any doubt?
Yeah, it's fine going. Thank you very much, Mayur, for your comprehensive explanation.
Yeah, yes.
It's clear. The only thing is that which I want to really highlight is that how about the use of Excel sheets, the BS spreadsheets?
Sorry, what?
BS spreadsheets.
Yeah.
So, are you going to provide the BS spreadsheets as well?
Yeah, absolutely.
Okay. And secondly, as you are saying, because what we used to do in the earlier stages is that we used to take the model and the complete design we never used to do in Etabs. Design we used to do manual.
Yeah, right.
By taking the movements and all these things. Whereas in your explanation, you're carrying out the design as well. So I think Etabs, while doing design, will be a little bit enhancing the ratios. Right?
No, it was earlier only. Right now, the software is a fixed. It gives you more accurate results.
More accurate. That's perfect.
Yeah.
That's perfect.
I guess you have worked on Etabs 7 or 9, I guess, right?
I was working Etabs 9.7.
Yeah, it was very old. So right now you are going to learn the structural design using the version 20. So it is more advanced. It will definitely give you the proper results.
Perfect.
Also, we'll get to see the manual design of a structural frames. Okay.
While applying the wind conditions, how do you apply the gust factor?
So it basically depends on whether the building is a flexible building or the rigid building. Okay, so if the building is a flexible building, so in that case only you have to consider a different gust factor. If it's a rigid building, then in that case the gust factor will be 0.85.
It is standard.
Yeah, it is standard 0.85 if the building is a rigid building. And when the building will be called as a rigid, when it will have the frequency less than 1 hertz. Okay, we'll talk about that one in a detailed way.
Okay.
Like it is very advanced parts. First of all, you need to understand basically the gust factor is nothing but the dynamic method of a wind
Yeah.
load. Okay, so before you get to dynamic method of a wind load, first of all you need to understand what is the static one.
Yeah.
Right.
Yeah.
Yeah, so you need to clear about the static method, then after only move towards the dynamic one. Any doubt again? Yeah, Sham Kumar, any doubt? Monisha?
Well, it was a good section.
Thank you.
But just I want to know, did you have designed any projects in Dubai? I mean, in
Yeah.
UAE?
Yes, yes. I have designed the villa projects.
Villa projects. Okay.
Yeah. Like basically the certain freelancer architects are there. Okay, so for those I provided the structural design and drawings to those.
Let me know, Mr. Sham Kumar, what's your doubt? I have designed many towers in Dubai. On behalf of the sir,
Yeah. Yeah,
Mayur,
Sham.
I'll just help you.
You can ask Afzal also. He has more than, I guess, a 40 year experience, right?
Yeah.
Yeah.
Go ahead with your doubt, please.
Yeah.
That also clears my concern as well, because
Yeah,
I am back into the structure since after a long time.
Right. Okay, Sham,
Well,
any doubt?
no, that's enough. By the way, I'm just new into this structural part, although I'm working in UAE.
That's good.
Yeah, so keep in touch with the Afzal, okay? He will help you.
No problem, Brother Sham.
Okay, thank you, Mr. Afzal.
Okay. Monisha, any doubt?
Hello.
Yeah, hi.
Hi. Actually, I have a gap. I already told you. I only have 2 years experience in India. But I'm not completely. I have no complete knowledge. There is nothing in structural engineering.
Okay,
Yeah.
it's fine only. We'll start from very basic only. You don't need to be
Okay.
expert on this particular field, okay? So we'll
Okay.
start from very basic only.
The session is nice. I like it, and I would like to join this. Yeah.
Yeah, thank you so much.
Okay.
You have any doubt regarding this particular program, you can just ask me.
Actually, how you provide the softwares?
Okay, so talking about the softwares, what you have to do is just send me your mail ID. Okay, so I will send you all the softwares file. Okay, that will be the zip file. You can just extract it and download the softwares. Okay, extract it and install it. Also, you'll get the tutorial from my site, like how you can install the softwares and how you can use those for the free.
But my system is a little bit old. Is there any problem?
Even if you are i3, I think it won't be there in any issue.
Yeah, okay.
Because I guess in 2016 I have used the i3. Okay, I used the
It's not
ETAP.
i3. I think it's i5. I think.
Yeah, it will be better then. There is no issue.
Okay, thank you.
See, all the softwares are very having this very small size. Okay, like if you take AutoCAD, it having something around 7 to 8 GB size. Okay, but the ETABS is having around 800 MB, so it is quite less. Okay,
less size.
So it won't lag. It won't lag in i5 or even in i3.
We can work very smooth and the software.
Yeah, obviously. Okay, so all the softwares like AutoCAD, Etabs is there. Those will be provided from my side. Whatever the Excel sheets you will need, whatever the codes you will need. Okay.
In this program, we will also learn the how to do with the softwares. Also, we will learn in this program.
Sorry, what?
in this program we can able to learn how to use the softwares also.
Yeah, obviously. Like I told you only, like in the first project only, we'll talk about the basics of the ETABS, like what basic operation you can do in the ETABS.
Okay.
Okay. Now, once you learn certain basics of the ETABS only, then in after that only we'll go for the advance, which will be covered in the G+5 residential building project.
Okay.
Okay. So in the G+2, first of all, we'll get to see how you can do the modeling. Okay. Like we'll see how to draw the columns, beams, slabs, and all. Okay. So once those are done, then we'll go into different one. Okay. So it's not about like, yeah.
Even now, I was trying to install these ETABS. The doubt which I have discussed with you earlier, the same is coming. ISEVRC file, the important file, which I am trying to copy to the root folder. Only that file is missing. Rest all, everything is quite comfortable. Even now, while your discussion, I was just trying to install it again, but I'm getting lost in that one particular last point.
Okay. Are you just extracting this file in a C drive?
Yeah. No, I'm downloading in my D drive, then copying into the computer instructions in the C program files.
So is it visible on the D drive?
No, not visible.
Okay, I guess your antivirus is still working.
No. Just now I have completely disabled it, and again I have applied.
Are you using a Windows Defender?
I'm using Windows. Which Windows I'm using? Let me tell you.
No, Windows Defender. It is the antivirus. Are you using that one?
No, I'm not using that even.
No, whatever the antivirus you are using, just turn off the real-time protection.
Done everything. And in fact, your patch file is also very good. It's perfectly all right. But the last part is getting some problem. I don't know the issue is from where. Usually it shouldn't happen like this. But for some reason.
Okay, so what we'll do is once this session is done, just share your screen to me. Okay.
Okay.
Yeah, we'll solve this issue. Okay.
Perfect.
Yeah, Monisha, about this basic operations, like so I was telling you about the first project. Like in the first project, the basics of the ETABS will be covered. Okay, like you will get to learn, understand how you can just start with the modeling. So basically, as I told you earlier, you can do the modeling using the two methods. The first one is a grid system method, and the second one is the center line method. Okay, so grid system method, you will get to learn that particular method in the first project only, which is a G+2. Okay.
I'm sorry to obstruct Mayur once more. Can we also learn how to extract directly from DXF file from AutoCAD to ETABS?
Yeah, absolutely.
Because rather, let us say, for example, if the plan is very critical in a trapezoidal plot, rather making the grids and the plot, it will be more tedious. So it will be more comfortable if you directly extract it from the AutoCAD itself.
Yeah, right. So that is what we are going to do from the second project only.
Okay.
So as you can see, the second project is a very tricky. Okay. So for that one, we have prepared a center line plan. So we are going to extract the center line plan, like we are going to import it into ETABS only, so that we can do a structural modeling in an efficient way. Okay. If you are going to do the modeling using the grid system, you can do it, but it will take a lot of time, and there will be more chances of the mistakes. So for that one only, we are going to do the modeling using the center line plan method. This will be the second method that will be used on every particular project. Okay, like for the G+9, G+12, for all these projects. Okay, but for the G+2, only the grid system method will be explained.
So the grid will be generated automatically by ETABS?
No, we will provide certain
data.
We are going to generate it. Okay. The data will be provided according to this only.
Okay.
What is the distance between the particular columns and the beams? According to that, you need to provide the grid dimensions.
Yes.
Perfect.
Yeah. Anything else?
Yeah, hi, how are you?
Yeah, hi, I'm fine. How are you?
This is Ahmed. Yeah, this is Ahmed from Oman.
Okay.
Actually, yeah, it's quite interesting course actually, and the syllabus is very, very interesting.
Thank you so much.
Just to highlight that I'm working actually in oil and gas company, and mainly we have this foundation for the equipment itself, the static equipment and the dynamic equipment. So I'm wondering if we could add one section for designing of foundation for something like compressors or pumps for that one, because it's quite also challenging one. And the other thing that if I'm also regarding the steel structure, can we add something in steel structure also?
Actually, I'm not that confident on a steel
Or the
structure
syllabus is
because
fixed?
honestly speaking, I don't have the working experience on a steel structure design. So that is the reason why I'm not providing the courses on a steel structure. Are you getting my point?
Okay. What about this, the foundations for?
Yeah.
Yeah,
What about
yeah,
the foundation?
it's very clear. So there's some kind of foundation for dynamic equipment, for compressors, I mean, or for a pump.
Oh,
And it's including also seismic and rotating equipment frequencies. So you don't have experience on that one also,
no,
right?
no. For the
حياك
buildings
أحمد، كيف
only.
حالك؟ حياك أحمد، كيف حالك؟
مرحبا بك. من؟
أفضل معك يا أخي.
Yeah, nice to meet you.
Which language you guys are speaking?
No, that was Arabic.
Sorry. Arabic.
Okay, yeah.
أقول
It
لك
sounds
أحمد.
great.
Yeah.
Nice. Yeah.
أحمد.
So basically the foundation design you are going to study for the buildings only.
Mayur, if you allow me, I'll just add something to Ahmad in this.
Yeah, sure. Why not?
I'll just speak in Arabic for him a little bit so that he'll be on the more comfort zone.
Yeah, sure.
أحمد أخبارك حبيبي تمام؟
مرحبا بك شيخ.
كيف حالك؟ وين أنتك بالمسقط وبرا؟ مسقط. حياك يا حبيبي، حياك. أقول لك في مشان foundation, مشان rotatory foundation or base slab. This is called basically as additional base slabs.
Okay.
This is called as additional base slab, which is under some kind of vibration. So it applies some dynamic effects. After inshallah, after Mr. Mayur complete his class, I will give my inputs in that. I have done a couple of foundation in Jabal Ali for Ras Al Khaimah Ceramics and Ras Al Khaimah Sugar Factory. Zain?
Okay.
After just understand the basic concept, what Mr. Mayur is teaching, he's going from the scratch actually. He's going from the scratch.
All right.
Same صف أول يعني.
Yeah. صحيح.
بعد خلصته هذا ميشن صف أول إن شاء الله تعالى أنا سوي ترتيب ميشن هذا ميشن base foundation for additional rotatory and checker plates.
خلاص noted. Thank you for that, man.
مشكورك.
Sure. All right. Thank you. Sorry for that, Mahir. Thank you.
Yeah, it's fine.
Yeah.
Mr. Afzal, you are in UAE, right?
I'm in Oman actually.
No, Mr. Afzal.
Afzal has worked in many places actually. I was in UAE, I was in Oman, and
no, currently where are you? No, currently where are you?
I'm in my sweet country, India.
Okay.
I'll be in Dubai shortly.
Yeah, in which company you were working?
I was working for the government agencies.
Government agencies. Is it a consultant company or
no, government in Ministry of Defense, Ministry of Information, like this.
Okay.
I was a lead designer.
Okay.
I was a lead designer for a long time, but thank God that I met with Mayur because I was totally into technical management and project management since last more than 12 years. Now I want to come back to my own bread and butter. I'm basically MTech structures. I have designed lots of structures in Dubai. One of the most iconic structures, which is Marina 101. Yeah, Marina 101 and Stallion Tower, Abjar Tower, and all this near your Marina and Business Day. But since 10 to 12 years, I have lost all my structural parts. So I just want to brush up. So I got my friend into touch, and now he's teaching me. Things have revised.
Great.
In which company you're working, Shyam?
I'm in a consultant firm. I'm into site. It's Geo.
Geo. Okay. Fine. Mayur, please continue, brother.
Yeah, I have nothing left to continue. I'm done from my side. If you have any doubts, just ask me.
Can we model one ground plus 2 building completely? Or we'll model along with you together so that you can check it like a homework?
Sorry, what?
Can we model one ground plus 2 structure first model?
Like a G+2 building
Yeah.
now.
If you want now or tomorrow, it's up to you, sir. You are our teacher.
It will take around 5 to 6 hours. Like we have to start from very basic only.
5 to 6 hours for modeling for ground plus 2?
Yeah. For the modeling it will not take 5 hours. At least it will take 1 hour, I think. But if you want to learn the whole design, okay, let's say if you want to apply the external loads also, and if you want to carry out the analysis and the design also, then from my side it will take 5 hours at least.
Because ground plus 2 will be totally static, no? So I
Yeah.
don't think it should take this much time. We'll not go into the detailing side. At least we'll design and model. It's up to you. It's up to you. You're the
Yeah,
decision.
sure. So we'll start that from the tomorrow. Okay, we'll have the 1 hour session. We'll do the modeling only.
No problem.
Okay, and so at the exact same time, 11:30. Fine. Hello, Afzal.
Yes, I'm with you.
Yeah. So 11:30 tomorrow.
Perfectly all right from my side. From my brothers and sisters, ask them.
Okay. So you guys.
I will give my full inputs, whatever you need. I'll give by the time tomorrow, hopefully tomorrow, after tomorrow, I'll extract very big models also, so that it will help for all of us.
Yeah, sure.
Because it is made in a hard drive. I don't know where I kept. I was searching when you sent me. I'm unable to find it.
So just get in touch with me once this session is done. We'll try to install the Etabs and just send me that E2K file as soon as possible only. So,
no, E2K file, that's what I said. It's in my hard drive. I'm unable to find it. I have a couple of models, very good models I have. I'll send it, but for sure I will find it.
Okay, fine.
For sure I will find it. I have very good models, along with architecture and structural plans.
Yeah.
Yes, Mahib, you're going to record all the sessions, right? Or because sometimes it will not suit our time, or how it will work this one.
This is basically a demo session which I give you.
No, not this one. I mean, the next sessions and all after registration and all those things.
No, it's basically a recorded program. So whatever the you are going to access the recorded sessions only.
Okay. All right. Okay.
You can watch the sessions at your own time. There is no issue.
That's good. Thank you.
Okay. So thank you so much, guys. It was great to have
Thank you.
Thank you so much for attending the session.
Okay, thank you.
So we'll have the session again on tomorrow. We'll talk about the modeling. Thank you so much. Have a great day. Not the great day. Good night.
Good night.
Good night.
Thank you.